Okay, so this is the part 2 of the trigonometry review for pre-calculus. We have a test coming up. So sketch or graph at least one period of the following. So we've got sine of x. So one period ends at 2 pi. The midway point is pi, halfway again, and halfway again. And sine has a maximum of 1 and a minimum of -1. And it starts in the middle. So we go middle, max, middle, minimum, middle. Make a nice smooth curve, no points. Nothing like this. That's bad. No. So cosine, we're going to use the same x values. Also goes from 1 to -1. Starts at a maximum, middle, minimum, middle, maximum. And with cosine, don't keep that going up. You have to turn it back around like it would continue in its pattern. Tangent. So I'm actually going to go -pi/2 to pi/2 for tangent because those are where our vertical asymptotes are located. 0, 0, pi/4, 1. -pi/4, -1, and it's an S type of shape. We can go out to 3 pi/2 for another vertical asymptote. And there's our tangent graph. So cosecant is the reciprocal of sine. So I think about where the sine curve would be. Like this. And anywhere sine is 0 is a vertical asymptote. Because when sine is 0, it's undefined. You can't divide by 0. And then our graph builds off of the max and min of sine, and there is one period for cosecant. So secant is next. That's 1 over cosine. I'm going to think about my cosine graph. I'll go back here to -pi/2. So there's a vertical asymptote at -pi/2, pi/2, 3 pi/2. And our secant graph is up that way, down this way. And there's half of that one other piece. And then cotangent is the reciprocal of tangent. So anywhere tangent was 0, so if we look at our tangent graph, can you see that? It was 0 at 0 and pi. So cotangent has asymptotes at 0 and pi, and again, it will at 2 pi. And cotangent of pi/4 is +1. Pi/2, it's 0. There, it's -1. And we still get this same shape, but curved in the other direction. So you can see there, let's do it this way. There's the difference between cotangent and tangent. Okay, sine has a period of 2 pi. Cosine has a period of 2 pi. So does cosecant, and so does secant. And tangent and cotangent each have a period of pi. Here's one pattern. It ends at pi. Sorry, I'm on the shaky table again, so the video keeps bouncing around. Sorry about that. To sketch the graph of secant, we look at the cosine function. To sketch the graph of cotangent, we look at the tangent function. And to sketch cosecant, we look at the sine function. The asymptotes for tangent, so here's my tangent graph, are negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and it would keep going. So a way we can generalize that, sorry, they're vertical, so it's S equals, is x equals n pi over 2, where n is an odd integer, meaning an odd positive or negative whole number. Negative 1, 1, 3, 5, 7, 9, and so on. Oh, okay. Change of types of questions here. Number 5 is the amplitude of this function is 1/2. It's from the coefficient. The period we get from the 1/4. The b value equals 2 pi over the new period. So to solve this, I'm going to cross multiply. So 8 pi is the new period. Horizontal shift and period. All right, so horizontal shift, negative pi over 4 means right pi over 4. And the period, well, b is 2 pi over the new period. Oops, and b in this case is 3. So we can cross multiply. 3 times the new period is 2 pi. So the new period is 2 pi over 3. Okay, write a sine function. Amplitude, that's the period. So b is 2 pi over the period, which is 2. Right 2 and down 3. Amplitude is 3. Amplitude is always positive. It is never negative. This negative is a reflection. It does not show in your amplitude answer. Okay, for the period, let me just show you something real quick here. There's a properties of proportions that allows us to switch these. So the new period can also be 2 pi over b. So that's just a faster way to get the period answer. So it's 2 pi over the 4. Phase shift is horizontal shift. This is left pi over 4 and down 5. This is a long review packet. There is a lot to do to get ready for your test. All right. 10, let me just label these A, B, C, and D. All right, for A, it says sinusoidal function. So you can pick sine or cosine. I will pick the one that makes the most sense based on where the graph starts. I like to find my midline first, or the vertical shift. That's here. You can find the midline by adding the max and min and dividing by 2. This is the amplitude, so that's 1. I'm going to pick cosine in this case since the maximum is on the y-axis. 2 pi over the period of pi. Oop, that's just 2. X and then minus 3. All right, so a nicer way to write that is cosine of 2x minus 3. For B, halfway between 1 and 5 is 3. So the amplitude is 2. I'm going to pick a sine equation since it starts in the middle and goes up. The period, all right, that's a little trickier, is from maximum to maximum. So 2 pi over 3 minus pi over 6. Now, we have the benefit of being able to use our calculator. So I'm going to do 2/3 minus 1/6 to find that length. It's a half. So the period is pi over 2. So the B value is 2 pi over 2, which is 2 pi times the reciprocal of the denominator. So that's 4, and then up 3. Because this one's so nicely labeled, I'll do a cosine function with the phase shift. The maximum is moved over to the right, pi over 6. So everything else about that equation is the same except for that phase shift. All right, C, wow, those numbers are tiny. We go from -7 to -1. So the midline is at it's an 8. It's at -4. The period goes over here to 4. So I'm going to pick a cosine graph. Here's the amplitude of 3. The period is 4, so the b value is 2 pi over 4, which is pi over 2. And last but not least on this page, halfway between 0 and 6 is 3. And since this is in the middle and goes up, I'm going to pick sine. Has an amplitude of 3, that's this length, at a vertical shift of 3. The period is 2 pi, so that's 1. You don't need all that space in there. It's 3 sine of x plus 3. Ooh, a word problem. Okay, the carnival Ferris wheel is shown as a diameter of 40 feet. So that means the radius is each 20. Makes 1 revolution every 20 seconds. The center is 21 feet off the ground. Sketch a graph. Oh, we got a nice grid down here. Okay, if t equals 0, is when the passenger is below the center. So if it's 21 feet from the ground to the center and it's a radius of 20, this seat is at a height of 1 foot and this seat is at a height of 41 feet. So my low is 1, my max is 41, and it takes me 20 seconds to go around, and it wants me to graph, it wants me to graph to 40. So halfway, halfway, halfway. Wow, this one works out with a really nice scale. Okay, so we get on at 0. We get back to the bottom at 20. So we're at the top at 10. Then we're going to be at the top again at 30 and the bottom again at 40. Write an equation. Because we get on at the bottom, I'm going to write a negative cosine graph because it's reflected cosine. You could do a positive cosine and phase shift it over to the right 10. Okay, so halfway is going to be 41 plus 1 divided by 2. It's 21. So that means the amplitude is 20. B is 2 pi over the period. So that's pi over 10. And plus the midline. If you wanted to write a positive cosine graph, it would look like that. How long after the start is the rider 25 feet? Oh, that's over here. 25. 3 decimal places. Okay. First thing to check. Is your calculator in radian mode? Mine is super. Now we're going to use y equals. In the first y equals, I'm going to type my equation. And we'll put 25 feet in the second. We got to go to our window and make it look like our graph here. So we start at time 0, we end at time 40. I'm going to say we start at 0 and our max is 41, so I'll go to 50. There's our graph. There's our 25 feet. So I want to find that first intersection. I'm going to do second trace. Choice number 5 is intersect. And I'm going to arrow to the right. Oh, no, see my blinking over here? I got to go way left. Here's a shortcut. I'm going to go up to the y equals 2 and then go left. That way I don't have to go around the curve. All right, my cursor is near that point. I'm going to hit enter 3 times. And we get 3 decimal places. So time is 5.641 seconds. Okay, sorry I paused because I think question D is the same as question C. How long after the start is the rider 25 feet above the ground? Here. When is the first time the rider is 25 feet above the ground? Well, that's here. I guess for C, just because I'm not clear, maybe I'll find this point, and this point is 2. We're going to do second trace, intersect, move over, hit enter 3 times, and that is also 14.359 seconds. .641 seconds. And I'm not finding the last one because this video is already long enough. Okay, number 12, doing it again. Ooh, the beach, my favorite. So we call it the shore because I'm from Philadelphia. Matthew is standing at the beach with his family and notices the water level changes throughout the day. The depth of the water decreases from a high of 10 feet above sea level to 4 feet below sea level. High tide occurred at 2 a.m. Low tide at 8 a.m. So that means, let's see, that is 6 hours. So 6 more hours. Here's how I figured that out. 8 minus 2 is 6. So 8 plus 6 gets me to 14 hours past midnight. We'll be back up at high tide. Great. Part B, write an equation. Depth equals, first I need the midline. 10 plus -4 divided by 2 is 3. So that means the amplitude is 7. I'm going to pick cosine because I know where the maximum is. The period is 1 full length, so the period is 12 hours. So B is 2 pi over 12. And there, oh, I used X, I should have used T. Okay, what will the depth be at 8 a.m.? So we're going to plug 8 into T, but not really, because they tell me at 8 a.m. is at -4 feet, or we would say 4 feet below sea level. And then D, when will the water be at 8 feet? So that's when 8 equals the equation. Oops. So y2, y1, let's do this. Oops, 7 cosine pi over 6 x minus 2 plus 3 and 8 But I'm going to fix my window to go from 0 to 14 hours. Let's go -5 to 13 because we went -4 to 10. So that just gives me a little extra buffer on the y scale. Okay, so we're gonna go second, trace, intersect is choice 5. I'm gonna hit my up arrow so I can go along the horizontal line. Hit enter 3 times. And that is 0.5119 hours after midnight. Let's find the next one. Second trace 5. Hit enter 3 times. 3.48. Hours after midnight. Because these aren't clock times, so that's why I'm writing hours after midnight. If I wanted to make them clock times, let's see, 0.481 of an hour is almost 29 minutes. So this would be 3:29 a.m. 0.519 of an hour. So that would be 12:31 a.m. for the first 2 times. Oh boy, graph 1 period. A is 3. Period is going to be 2 pi over 4, which is pi over 2. That's annoying. I don't need that. C is right pi over 4, and there is no vertical shift. But I can't forget about the reflection. Okay, right pi over 4, and I need to go a period over. So to find the endpoint, I'm going to do pi over 4 plus pi over 2. That's going to get me a distance of pi over 2 away. I'm going to ignore the pi's. Instead of adding my fractions by hand, oops. So that's going to be 3 pi over 4. Now I need the halfway. So there's a calculation way to do this, or a pattern. You can say what's between 1 and 3, and that's 2 pi over 4. Or you can find the midpoint, where we would add up the endpoints and divide by 2. Now 2/4 is pi over 2, but I need halfway and halfway again. So let's use our calculator. 1/2 plus 1/4 divided by 2. So that's 3 pi over 8. I got to do it one more time this way. 1/2 plus 3/4 divided by 2 is 5/8. With an amplitude of 3. 1, 2, 3. 1, 2, 3. It's cosine, but reflected, so it starts minimum, middle, maximum, middle, minimum. And there is 1 period of number 13. Let's do that 2 more times. B. Amplitude is 1, but there's a reflection. Can't forget that. B is 1, so the period is 2 pi divided by 1. That's nice. C is to the left, pi over 2, and D is up 3. Okay. Up 3 is my new midline with an amplitude of 1, so that's going to go from 2 to 4. Left, pi over 2. And I need the ending of my period, so I'm going to do 1/2 plus 2. Because I need to go 2 pi away. And that is 5 pi over 2. Now I need halfway. which is pi. Then I need halfway again. Uh-oh, my scale is going to be a little off because of the y-axis. That's okay. That's pi over 4. And then halfway again. Seven pi over 4. It's a sine graph, so we start in the middle, go to the minimum, back to the middle, to the maximum, to the middle. Because it was reflected, that's why it goes down. And there is one period of the sine graph. And our very last problem. Down 4, right pi, 2 pi over 2 with an amplitude of 4. And this one is way easier with a scale, except I need a longer y-axis. So an amplitude of 4 up gets me to 0. 4 down gets me to -8. We start to the right pi with a period of pi. So 1 plus 1 is 2. Halfway, so let's see. 2 plus 1 divided by 2 is 3 pi over 2. Oh, sorry, math enter, fraction 3 halves. Halfway and halfway. Pi over 4. And then again, oops, 2 plus 3 over 2 divided by 2. It's 4 pi over 6. No, whoa. Look at what I typed there. That's crazy. Miss Wee, slow it down when you type. I'm just so excited to be at the end of the video. There we go, 7 pi over 4. It is cosine. So we start at a maximum, go to the middle, minimum, middle, maximum. And there is one period of that cosine graph. Yay, we're done.